because that's when it hits 0.
This one?
And when that's 0, yeah.
Okay. Now.
But, well.
So this is my no. That's my inflection point.
Well, you need to. What you want to do is slide it over, so you have to have the function change. So move that over, I guess. Move it over that way some more. A little more. No, that's just raising it up and down. Move it over to the left. A little more, like about. You can do it more like 4. I mean, change the number. Like change. You can change it to like 6. Just keep going.
Yeah.
Alright, now raise the whole function up. No, leave that on. Just raise the function up. A little. Alright, that's fine. Now see where this is 0.
Yes.
The purple function. Where's the purple function 0? You can just go on the graph.
This is inside the LN, right?
Just put your mouse on the
LN's
graph.
already there, right?
Okay.
Okay, so this one
Right there.
goes
That's 0
0
at negative
So it's on 3x.
4.74.
When this
Yeah.
goes to
So
0,
define
so you get to
this.
1.
This
Under 1.
stops at
But LN of
4.7.
1.
So that's my
Zero?
inflection point.
Right, so it's 0, 0.
No.
Oh, okay.
This is
So from here
right
you
now.
would
We're
just
just
put
trying to
the
make the
derivatives
graphs
in.
continuous.
Yeah, the time here is a little complicated
It has
because
the
it's
exact point where 1 stops.
Chain,
Yeah.
you got a couple chains there. Right?
Yeah, so
Yeah.
the 1 will
So
cosine
you're
3x,
saying
and then it
you're
would
telling
be
it to
negative
stop.
sine
You want
of
it to
3x,
stop
and
at
then it would be 3.
4.74.
Okay, very good. Yeah, that's right.
Because that's where this
And
one
this all
starts.
chimes each other, right?
And then make that one
Right,
start.
bottom
Okay.
will be 30, right? You still got
Good.
the 30x on the
Now
bottom.
Yeah,
your
the 30x.
That's
inflection
right, yeah.
point is right there at 6.
Okay.
So,
Negative 6.2. This is my inflection point.
wait, you don't need to draw a graph for it. Okay? That's your inflection point.
Alright, so I'm done with the graph.
Wait, what's? Oh, yeah, you have everything.
Alright.
Like when I did mine, I made sure all my points, like my inflection points, were at like 0, 1.
Yeah.
So easy. Just because now those are decimals, it just makes the math a little bit harder.
Yeah. We're good?
Yeah.
Okay, so now, how do I sign in first? I can actually like save this to my document. Get an image of this. Shoot.
Alright, 4.8.
So, let's see.
Looks like we developed a bunch of rules for derivatives. Power rule, distortion rule, I'd like to now work these processes. Be able to undo the derivative process, undo it. In this section, I will look at the most basic antiderivative processes possible to do. And it's safe for later coursework in Cup 2 to undo things like product rules and other such more complicated procedures. Right. So undoing derivatives. Since we know that the derivative of x to the n is n x to the n minus 1, what do? You pull down the power and you lower the power by 1. So we want to do that process. Right? Should I have, this is the antiderivative symbol here, right? It says take antiderivative. That's what the symbol is trying to say. That's the process you're supposed to perform when you see that symbol. So take an antiderivative. As opposed to the ddx symbol, right, which says take derivative. This says undo that. Now, this symbol is called an integral symbol. Okay? For later work we'll do in chapter 5. We'll use it there much more frequently than in chapter 4. It's only this one section. So this right now is called an indefinite integral, as opposed to the definite type we'll have in chapter 5. Definite integral. So taking antiderivative and the words indefinite integral are the same to us, and they are this curving line here. So instead of taking the derivative of a power function, I want to take its antiderivative. I want to undo some derivative process after a function and give me x to the n. I want to undo that. Now, on the right-hand side of this symbol is a dx symbol. These two go together, right? So that, along with the dx symbol, those things together say take antiderivative of function inside. Take antiderivative of x to the n. So how will you undo that? You know that to get to this expression, you pulled down the power and lowered the power by 1. Right? To get to this function, right, you differentiated something, right? You took the, here's what the question's asking. You took the derivative of some function, and it gave you x to the n. You want to find out what the original function was. What is the original function you started with, right? Find the original f of x before derivative is taken.
You get rid of the n in front, and you do n plus x to the n plus 1? Or depending?
So just do it in the opposite order. Here, you took down the power and then lowered the power by 1. Right? You multiplied by the power and then lowered the power by 1. Undo that process.
Divide by n and then raise the power by 1.
But do it. So the last thing that happened here is the first thing you need to do on the other side. So since the last thing you did was lower the power by 1, you need to do what? Over
Add
here?
the power?
Raise it by 1. And then you'll
Divided by n.
then you'll take care of that piece. Then you'll divide by the first thing you did, right? The n plus 1. So the answer is, exactly what Justin said, I'm going to raise the power by 1, x to the n plus 1, and then I'll divide by n plus 1. Okay. That's how you undo any power. It's the antiderivative of any power. Except for one case.
You have to add the constant.
Oh, that's, yeah, you got me there again. So plus c, plus an arbitrary constant. Because we know that any constant, when you take its derivative, goes to 0. So therefore, this could have had plus 1 added to it, or plus 2, or plus anything, plus 0. Okay? So anytime you take an antiderivative, when it's an indefinite integral, it's just these symbols, you always want to put a plus c on the end of every single one. Always put plus c. In chapter 5, we will alleviate this need for the plus c when we take definite integrals. It won't matter then. Okay? But right now, you can always put a plus c. All right. So that's the first one. That's the major one for you guys. So now, the other ones are just the reverse process of what you already. So, what would be the antiderivative of, just go in order here, of sine x? So you got to ask yourself, what did you differentiate to get sine x?
Cosine?
Cosine x. But if you differentiate cosine x, you'll get negative sine x. So I need negative cosine x as the answer.